Welcome back, chemistry fans. Got a homework assignment for you, assignment 4.2. Let's go over that right now. All right, so in this first one, it's converting 5 moles into liters. And you're like, oh, that's a new unit. I'm not sure how to go about it. So we need to refer back to our mole map. In your mole map, you have moles going to grams, you have moles going out here to atoms, or it could be molecules. That's why they call it fundamental units. And then there was this other part of it over here with liters. In each of these cases, if you start with moles, you will be multiplying. If you go reverse, go into moles, it's going to be a division process. So keep that in mind as we're trying this number one. So we are starting with moles. So we're starting in the middle. And we are moving down to liters. That means we are going to multiply. So I'm going to take 5.0 times the conversion for liters is 22.4. The conversion for grams is on the periodic table. The conversion for atoms is Avogadro's number. All right, so I'm going to end up with 5 times 22.4, which is exactly 112. Well, the only problem is I got 2 sig figs, so your answer actually, ironically, ends up being 110 liters, so that it doesn't have the right, so it does have the correct number of sig figs. All right, number 2, I've got now going into, I've got going mass from molecules. Now, this is a big one. This one is going to take several steps. So my mass starts out here, and I want to end up over here with molecules. There's no arrow that goes directly from grams to molecules. So we have to go through moles. So this is going to be a 2-step process. So we're going to start over here with molecules, 4.1 times 10 to 78. And notice that the arrow is going into moles. That means we're going to divide by 6.02 times 10 to the 23rd, which is Avogadro's number, and then we're going to multiply by the weight of carbon dioxide. Carbon dioxide is CO2, and that's weight is going to be somewhere right around 44 if I add it up off the periodic table. So I'm going to plug this in one step at a time. 4.1 times 10 to the 78, and that is hard for you to see quite possibly. Oh, you know what? Here's what we're going to do. We're going to stop sharing. Now you'll be able to see it a lot clearer. Notice what I did. So here's what I'm going to try and do. I'm going to put these values in as I am entering it. So here we go. Oh, this is interesting. 4 point, what is the value again? Hold on, 4.1 times 10 to the 78. All right, let me bring that camera back up. 4.1 times 10 to the 78. 4.1. So I'm putting in the 1. Now here's where I get the times 10. So I do second. And see that button right above the 7? It has a little EE there. Push that. And then I can push 78. And what I get, oh geez, 4.1 is that after I push that series of buttons. 4.1 second, and that comma gets the EE. That will make it to the 78. So I'm going to take that value now. I'm going to divide by 6.02 times 10 to the 23rd. And I did the exact same thing. And I get 6.8 times 10 to the 54. But that's not my answer. That's moles. So now what I got to do is I got to convert that into grams. So my last step is to multiply by the weight off the periodic table. And I end up with 3 times 10 to the 56, because I got to cut off some of those sig figs and they're all going to round each other up. So let me share my screen back now to you. So that's going to end up being 3.0 times 10 to the 56 grams. I don't think there's that much carbon dioxide in the whole universe, but that's okay. Oh, that was the end of our problems. Those were the two answers. Oh, good. So we're done with the homework. Thank you very much for watching. We'll practice this more. Talk to you soon. Bye.